What you're going to notice on this slide is again some math terminology. But what they're looking at is what happens when I have the square root of a variable with an even exponent versus the square root of a variable with an odd exponent, right? So the square root of a variable with an even exponent always works out nicely, right? Because that one's x to the 3. And why it is because, remember, square root, the index is 2, which means if I rub this out, right, I have x to the 6 divided by 2, and that works out really nicely as x to the 3. Okay? It's true for all these even numbered exponents. So if we go over here, x to the 8, well, my indice is 2, so 8 divided by 2 is x to the 4, right? Whoa, that's an ugly 4. Okay. So it's always true that the square root is just the number divided by 2, so x to the 6, the square root is x cubed. If it was x to the 28, then it would be divided by 2 is 14, it would be x to the 14, right? The change is if I have odd exponents, right? What I can do is I can do this. Remember, the indice is still 2, but if I do 7 divided by 2, I'm going to have x to the 3.5. And that doesn't work because we're looking for integer exponents. We're not looking for fractional exponents. But I could say this is the square root of x to the 6 times the square root of x. Square root of x to the 6 times the square root of x. Okay? So if I do that, well, I know the square root of x to the 6 is x cubed, so I get x cubed root x cubed root x. Okay? So you still have the root x, but again it's smaller because most of it has gone out of it. So we'll just look at that for a second. Okay? All right. Similarly, this one here, okay, because all the even exponents are perfect squares, okay, I can take x to the 8th times x, right? 8 and 1 would be 9, but we know that x to the 4th, right? So again, we've got most of the exponents out, but we are still left with a square root, unfortunately. And that's what this slide's talking about.